So in algorithm analysis, what happens essentially is, so far we have learned about the business processes, then we touch based with the robotic process automation part, wherein we identified the repetitive processes and the processes which are manual in nature. Then we covered something called as business rules. So business rules and business processes goes hand on hand. So without business rules, your business process is incomplete, and without business process, your business rules are incomplete. Now, in similar lines, we have something called as algorithm. Now, algorithms are your actual business logic which powers your business rules and business processes. So let's say I have a process of uh, doing any XYZ task. I would be having some business rules incorporated with it. After the execution of the business rules, the final calculation would be in the form of algorithms. For example, if I had to calculate a premium of a particular insurance product like auto insurance or homeowners insurance, I would be having a set of processes like the agent to quote process, or quote to bind process, or new business process, renewal process, rewrite process. Within those processes, I would be having certain set of business rules like who should be able to issue the policy, what all information can be taken up, whether the insured is eligible for that particular policy or not. If eligible, what are the necessary set of criterions basis on which the policy would be issued. So those are your business rules. Now, what are business algorithm? Business algorithm are your business logic that helps us calculate the premium for that particular insurance. I mean, the insured who is seeking for that particular policy. Now, this calculation has certain set of methods or certain set of guidelines that they have to follow. Now, essentially, when we calculate something for a particular system, we would always be having certain statistical table. Because if you consider an insurance product, now the premium for a person who falls under age group 25 to 30 would comparatively be less than the premium for a person who falls in the age group of 40 to 45, because the risk increases, so the premium amount increases. Now, how this increasing thing happens? This happens basis on the statistical tables which we receive as a business analyst in our project, and basis on those statistical tables, we have to develop a particular algorithm. Now, those algorithm would be responsible for calculating all your insurance final premium. So we would be adding different factors into it, like the age factor or the driving history factor. So all this factor would be having a supporting statistical table. Now, this is not the case within insurance industry. Whichever industry you work, basis on the model and basis on the statistical tables, you should be able to develop a particular algorithm. Now, as part of our regular business analysis artifacts that we deliver, for example, the business requirement document or functional specification document, we also deliver this rating calculations, which is part of your algorithm analysis, wherein we explain our stakeholder what and how we would be applying the rates from a system context, how the system should be able to apply the rates basis on different parameters that has been captured by that particular system. Now, these factors would be having different set of parameters to assess. For example, the age factor, whether the insured falls between 25 to 30 or 30 to 35 or 35 to 40, what should be the premium impact for those factor, or the driving history factor, or the violation factor, or for that matter any discount if you want to apply, how the discount calculation should happen in that particular insurance policy. If he is taking any additional coverages, how that calculation would be happening. All those factors would be cumulatively considered when developing a particular algorithm. So in our today's session, we are going to cover what is algorithm analysis, how and where we get the information about the algorithm, what are algorithm factors, and we would see a sample case study. Now, like I say, The algorithm analysis is an important part of your computational complexity theory, which provides theoretical estimation for the required resources of an algorithm to solve a specific computational problem. So this is wherein we take the business facts and figures into consideration. Basis on those business facts and figures, we develop our algorithm, which we would be using for our computational purpose. Towards the end, whatever would be the need of that particular algorithm, the system should be able to provide those outcomes. Now, when we see algorithm in a particular software application context, there are two sorts of algorithm. One is the business algorithm. The example which I said, it would be driven by your business processes and business rules and the statistical tables. Then there is the second category of algorithm called as system algorithm. Now, system algorithms are essentially your non-functional requirements, or it would be derived from your non-functional requirements aspects. For example, the scalability of a system, the performance of a system, or performance tuning of a particular system. Now, the coders do write algorithm for these purposes as well. Now, those sort of algorithm would be part of your system algorithm. Whereas the premium calculation or any XYZ calculation which caters to a particular business need are called as business algorithm. So your application would holistically be hosting these two category of algorithm, the system algorithm and the business algorithm. Now, system algorithm is something that comes under the scope of your development team, whereas the business algorithm is something that falls under the scope of business analysis team. Now, if we consider the source of algorithm, there are various sources which we need to refer when we tend to design a particular algorithm. For example, the statistical table. The example which I already gave you, we would be getting statistical table from our business users or the underwriting manual. They would be creating those table and giving it to us. We would be analyzing those table, and we would look into a particular opportunity wherein we could include those particular tables into our final premium calculation if it is in insurance industry. Then there are business rules, there are business processes, and then there is a model. Now, every algorithm has to follow a certain set of model. For example, we have a very common model called as supply versus demand model, wherein we see basis on the demand, basis on the supply, we assess the demand, and basis on the demand, we assess the supply. The pricing would completely depend on the demand and the supply. These are the two important factors basis on which we determine our prices. If the supply is low and the demand is high, then the prices tend to increase. If the supply is high and demand is low, then the pricing decreases. So this applies to every industry. So this is not the only model that we need to take into consideration when we are designing algorithm. There are various other models as well which we need to consider when we are designing the algorithm. Now, one obvious question that may come over here is, who would give these statistical tables and how these statistical tables are written in actual practice? So, if you consider the insurance industry, there is a team called as actuarials. So, these actuarials are the people who are essentially responsible for defining the statistical tables, like how the rate classification would happen basis on the risk that they want to insure. So this actuarials would write this particular rating statistical rates. Now, the process doesn't end over here. Once these actuarials write these statistical tables, the process doesn't end over there. It has to be formally approved by the governing agencies like the state laws or the federal laws. They would be approving these rates. Only after that, these rates could be applied on your final insurance product, and after which we get the final estimated premium. So whatever information or the whatever statistical tables that we receive from the business stakeholder, they are essentially the rates which are approved by the state laws or the federal laws. Because if they are not approved by the state or federal laws, that would bring in legal or compliance issues for that particular product. Now, once we receive that, as I said, we would go on designing those particular algorithms. So algorithm are nothing but we would pick some rates from a particular table. we would pick certain rates from particular table. If we want to apply a particular factor, then we multiply that rate with that particular factor, and then we go on adding step by step. So step 1 is determining the age of the insured. Step 2 is determining his driving history. Step 3 is determining the coverage prices. Step 4 is like if there are any additional information, then the final premium would be step 1 plus step 2 plus step 3 plus step 4. So that would be my final premium that would be calculated. Now all of these things would be included in the form of an algorithm which is configured into our software application. Now, like I said, there would be different factors for it. Now this factor could be anything depending on the industry or the project that you are working. This factor, the very common factor would be age, expenses, losses, probability, rates. These are some of the common factors that would influence the calculation of our algorithm. Now this is an algorithm that I have created for our easy understanding. So this is a search pricing model for our ride hailing applications, for example Uber. Now what happens over here is, if I open this particular sheet, the core need of a particular rider like you and me is to reach from one destination to another destination, that is destination A to destination B. Now, in this process, when we open our Uber app, there are certain things that are happening in between. Now, it is not only that I am looking for a destination and it would match me a driver and give, I should be able to onboard that cab and reach destination B. There is a certain set of processes that happens in between, basis on which my search prices increases or decreases. Now, what are those factors? Now, if you see, the very important factor is driver availability radius, like how near that driver is available to me. After that, how many numbers of drivers are available for to take my request. So if the number of drivers are more, the price would be less. If the number of drivers are less, the price would be more, depending on what destination I am going to. So let's say I assume that the Uber application is searching for the driver within a radius of 0.5 miles. And within those 0.5 miles, it would calculate how many number of drivers are available. Now it gave me a number of drivers over here. Now the second factor that it would take into consideration, the system algorithm, is how many number of people are requesting for a cab at the same time. If the number of requests are less, then the price would be less. So it is like these two factors go hand on hand. The number of drivers more and the number of ride requests are less, the price would be less. If the number of drivers are less and the number of ride requests are more, then the price would be high. So essentially here, what what model comes into picture is demand versus supply. If you see, the supply, drivers are nothing but supply, and demands are nothing but the riders who are requesting for that particular cab. So if the supply is more and the demand is less, the price is less. If the supply is less and the demand is more, the price is high. Now after that, after applying that demand versus supply model in that search pricing algorithm, we have something called as app refresh intervals. Now what is app refresh interval in this case is, let's say I requested for a particular driver and I see there are 20 drivers available and riders are only one. Okay, so the app would keep on refreshing itself after every 15 seconds. So why it needs to refresh itself after every 15 seconds? Because it has to match the demand versus supply mechanism that has been implemented in that Uber logic. Now after every 15 seconds, it would check what is the current status of the request, how many drivers are available, how many riders are available. Basis on that, it would determine its prices. So that's the reason why we have a app refresh interval over here. After that, we have the base price calculation that we receive from our business stakeholder. So base price is depending on the cab segment that we want to onboard. if that is a luxury Uber segment or Uber Go segment or Uber Black segment. Basis on the cap segment, we have a base price calculation. So 40 is the base price for that particular segment, this luxury segment. After that, we need to apply the right time prices. Now, right time prices is something that is also provided by our business stakeholder in this particular case. So these are essentially the base rate which are provided by your business stakeholder: the driver availability, the app refresh interval, the base price, and the right time price. Like what would be the right time charges for that particular journey. So $1 per mile, that would be the sorry, $1 per minute, that would be the right time charges. Then there would be the right time. Now, right time is the distance between destination A and destination B, which is the estimated distance the app gives to us. That destination A to destination B, it would take you approx 15 minutes. So that is your right time. After that, you have the per mile calculation. What is the base rate for per mile? So let's say, depending on the segment, whether it's Uber luxury segment or Uber Black segment or Uber Go segment, it should give me a base per mile charges. So that is something that I am going to apply. After that, depending on your destination, from where you are starting till your end destination, you would be having a calculation called as total miles. So total mile is nothing but your approximate distance between destination A and B. So this total mile would get multiplied by your per mile price, and your right time would get multiplied by your right time price. So this is our base calculation that we have. Now here, the green part is something called as constant. These information would never ever change. These are the information which are provided by your business stakeholder. Okay, this information would never ever change. The base price won't change, the app refresh interval won't change, the right time price won't change, the per mile price won't change. But there are certain things which are highly recommended to be changing. So those are called as dynamic data. So you divided your algorithm into two parts: the constant data and the dynamic data. So constant data is something which is highlighted in green, would never ever change, and the orange data are your dynamic data, which would change basis on the situation of the request. Now, when we apply all this thing into one algorithm, so this is our final algorithm. So if you see, the final algorithm would be like this: the base price, what is the base price in this particular case? 40, plus of right time price, that is 1. How much time is the right time price? That is 15 minutes, that is 1 into 15, plus of the per mile charges, that is $9 per mile, into how many miles? That is 2. So 2 is the total distance that we cover. So your final algorithm would be 40 plus 1 into 15 plus of 9 into 2 into the surge factor. So depending on this demand and supply, the surge factor would get applied to the overall calculation. So your surge factor would be into 1. If the drivers are more and the riders are less, the surge price would be 0.1. So it would give me the surge price of final destination. If the number of drivers are less and the number of riders are more, the surge price would be more. It would be 2x. So this is the surge price for 0.1x, 1.1x, 1.2x, 1.3x till starting from 1x, 1.1x, 1.2x, 3x, 4x till 2x. So this is how your application algorithms are designed. So you would have all the factors classified first, then you have to identify which are the dynamic data, which are the constant data, and then you would create an algorithm of the final price, wherein you would add up all the factors and multiply it with all the constant or dynamism that you have in place, and then you would calculate your final price. Now, in this particular circumstances, this is fine. We have developed the algorithm. There are certain other things that you need to take into consideration, like the prerequisites, who are the actors, what is the business scenario, and what or what is the way how this algorithm would work, and what are the business rules that will taken into consideration. If you consider the prerequisites that needs I mean that would be taken into consideration here, the prerequisite would be rider ABC has the ride hailing service provider's app installed in his mobile. So that is the prerequisite, without which the functionality or this business outcome that we are expecting will not be applicable. Now, the second prerequisite would be rider ABC's mobile internet and GPS is turned on. Why GPS is turned on? Because GPS is necessary in order to come up with an estimated fare from distance A to distance B. So that is a prerequisite. So prerequisite 3 would be rider ABC has a start point and the end destination. What is his start destination and what is his end destination? Without which the demand versus supply model won't work. Why? Because we won't be able to estimate out what would be the final exact pricing for reaching from destination A to B. So these would be the 3 prerequisites that we need in order for this example to execute. After that, we need to have certain actors in our system. For example, I have the rider ABC, I have the drivers, and I have the ride hailing app system itself. So system itself can also be an actor. Now, when I say ride hailing app system is an actor, so which is the factor it is contributing when it applies itself as an actor? So this is the app refresh interval. So every 15 seconds, the app get refreshed itself. So this particular actor is contributing essentially for this thing, because for after every 15 seconds the app gives you a newer dynamic pricing, whether it's low compared to the earlier price or it could be less compared to the earlier price. So that is the actor the system itself is playing over here. Every 15 seconds it's refreshing its pricing model. Now, after understanding the actors, we need to understand the business scenario. Now, business scenario here is, let's assume in the below table, rider ABC is requesting a ride at destination in order to reach to destination B. Like I explained you here in this particular business scenario, rider A wants to reach to destination B. Now, when I have to explain this algorithm to the development team, how do I explain it? So these are some of the situation how I can explain to the development team. In the context of the above scenario, ride hailing app performs a check at destination A as below. So the first step what it does, it scans the GPS radius up to 0.5 kilometers. So the base scanning radius which we have defined. After that, to find the number of available drivers. After that, it finds the number of drivers. First, it scans the app radius basis on number of drivers availability, and it checks what is the number of drivers available. So that is step 1. Step 2 is it counts the number of available drivers within the GPS radius up to 0.5 miles. So essentially it's not number of drivers, it's actually number of riders. Okay, so in step 3 it calculates in step 2 it calculates the number of riders in that particular destination A to destination B. So that is step 2. In step 3 it scans the GPS radius up to 0.5 miles from destination A to find the number of riders in destination B, like ABC. Like ABC, there would be multiple people who wants to travel to that direction. So now it calculated the number of riders. Now in step 3, what it is actually doing, it is actually calculating how many number of riders are heading towards destination B. Here it only calculates the generic number of riders, how many riders are available. But now the algorithm has to match in such a way that how many riders are heading towards destination B, the similar riders like rider ABC. So it has to do a match. After that, it scans the number of rider requests within the GPS radius of 0.5. Now, in order to perform step 1 to step 4, the app takes approximately 15 minutes. So whatever classification and matching, whatever it happens, it essentially takes 15 seconds. After every 15 seconds, the app refreshes itself. like I mean, you have explained it in your particular explanation. Now this is about the processes that which it would follow. Now we have the prerequisite, we have the actions, we have the business scenario, and we have the necessary set of processes. Step 1 to step 2, step 3, step 4, essentially the business process. Now we come to the business rules. Now business rule over here is, if no drivers are, if number of drivers are equal to or more than number of riders, then there is no surge price charge. Now in our case, if these two things are equal, then there won't be any surge price. Now why I say there won't be any surge price? Because the demand and supply are in equal situation. So there is no possibility of increasing the surge price. So this model would only work when there is a fluctuation between the demand versus supply. If both are equal, there is no point including a surge price. So that is your business rule 1. Business rule 2 would be, if number of drivers are less than the number of drivers, then a multiplicative surge factor is applied, like it is happening in this case. So as the number of drivers are decreasing and the number of riders are increasing, there is a multiplicative surge price that is being taken into consideration. That is business rule 2. Now business rule 3 is, surge factor is a multiplicative factor charged to the cumulative fare consisting of base fare plus ride time rate into total ride time plus per mile rate into total number of miles. So essentially the surge factor, it is getting applied to the overall calculation. It is not getting applied to only a single factor. So that is what my business rule 3 talks about. After that, whatever the table that you have developed, you can include that particular table for a easy illustration of what you want to convey. So whenever you are working as a business analyst, whenever if someone asks you to design a particular algorithm based on certain facts and figures that they have provided, you have to first understand the prerequisites. You have to then identify the actors. What is the business scenario? Then you have to define the business processes, you have to apply the business rule, and then you can go on designing your algorithm, wherein you have to understand the model behind that particular algorithm, whether it's a demand versus supply model or any XYZ model that is there. Then you have to identify how much are the constant data, how much are the dynamic data, and what is that multiplicative factor. And after that, you get your final pricing calculation. Now, this was a example of the luxury segment of Uber. So similarly, there would be multiple other segments in Uber, like Uber Black, Uber Glow, Uber Go. So there the calculation process would be same like we followed here, but the factors would be different. So here the base factor is 40. If it is not a luxury segment, the base factor would come to 30. If the ride time price here is 1, for the other category of Uber segment, the ride time fare would be 0.8, 0.5 and so on. So the algorithm would remain same, but the factor would be different, and that would directly impact your pricing calculation. So once you design a particular algorithm for a particular system, you can customize that particular algorithm basis on the products that you are configuring that algorithm for. So same thing happens in insurance domain as well. We have a certain set of factors, we have some constant data, we have some dynamic data. Once we design the algorithm for, let's say, auto insurance, once the auto insurance work gets ended, we tend to use the same algorithm calculation methodology for homeowners insurance. Now in that particular calculation methodology, we tend to just change the factors, like the coverages for auto insurance won't be same for coverages that is offered by a homeowners insurance. So we replace it with the we swap it with the coverages, then we swap it with the base rates calculation of that particular coverage or the discount factors that are applicable for those particular products. So similarly, any industry you consider, you have to create certain set of algorithm, and you have to get it approved by your business stakeholder along with other requirements as well, because algorithm is essentially the brain of your system. If your algorithm is not working properly, then your system is incompetent or it would not be approved or not be acceptable by your end user. So to summarize, we understood what are algorithm, what is the source of algorithm, what are the algorithm factors, and we saw an example of algorithm. Any questions, anyone?